Hammer is a significant leapfrog in performance beyond what is in the drone industry today. And Grease Lightning is a significant leapfrog in performance beyond our Hammer product line. Grease Lightning can take off and land vertically like a multi-rotor, maneuver like a multi-rotor, and fly missions of 14 to 20 hours.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 337. How can hybrid-powered drones benefit enterprise operations? For that question, we head to Virginia and speak with Bill Fredericks, CEO of Advanced Aircraft Company. Advanced Aircraft Company, or AAC for short, designs long-endurance hybrid electric UAS, targeting the commercial and military markets. AAC's design philosophy is simple: fast, innovative, and safe. Their products feature streamlined aerodynamic designs, hybrid electric propulsion that allows for longer flight times, and rigorous safety procedures that can be employed if the combustion engine fails. AAC's first product is the Hammer UAS, a long-endurance multi-rotor utilizing hybrid electric propulsion and patented aerodynamic design features. The Hammer can fly for over 2 hours while carrying a payload of 4 pounds. The company's future product is the Green Lightning UAS. AAC has licensed production rights from NASA for the Grease Lightning and will improve on the technology to produce a UAS that will fly for 19 hours with a 5-pound payload. This unique aircraft can take off and land without any launch and recovery equipment. Bill is an accomplished aircraft designer who has designed dozens of aircraft, 12 of which have achieved first flight. Before founding Advanced Aircraft Company, Bill was a valued aeronautical engineer at NASA Langley Research Center in the Aeronautics Systems Analysis Branch. He is the lead inventor on the Grease Lightning patent and led the project from its conceptual design through its successful flight testing. In this episode of the Drone Radio Show, Bill talks about Advanced Aircraft Company, the benefits of hybrid propulsion systems, and how Hammer and Grease Lightning systems can benefit enterprise organizations. But before we hear from Bill, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how hybrid propulsion systems can extend the value of drones with Bill Fredericks of Advanced Aircraft Company. Let's pick up the interview where I asked Bill to introduce himself.
Hello, everyone. Good afternoon. I'm Bill Fredericks, founder and CEO of Advanced Aircraft Company, and I lead this wonderful team to make the world a better place by making high-performance drones.
Bill, tell us about Advanced Aircraft Company.
Great, thank you. So we're an investor-funded startup, and we're focused on solving a really sharp economic pain point. So, and that pain point specifically is, if you look at the drone industry today, first of all, the drone industry is a really interesting market and use case, as I'm sure the audience of this show already recognizes. The other thing that's interesting is really the first wave of the drone industry was the consumer drone industry. And the second wave of the drone industry is the enterprise use of drones. And that's where the business models start getting really interesting and exciting. So if you look at the industry today, not a lot of enterprise level corporations are using drones. However, It's the compound annual growth rate of enterprise corporations using drones is over 50% right now. So enterprise corporations are starting to get on board with collecting data from drones to operate their enterprises more efficiently, which is very interesting. If you look at most of the drones manufactured out there today, they're all battery powered. And the big pain point with battery powered drones is the limited flight time. And that creates an economic pain point because in general, our customers, the UAS service providers, or those enterprise corporations that have in-house drone operations to their own W-2 employees as pilots, in general, they're collecting data by the acre and paying their pilots by the hour. So productivity is a key metric of interest for them. And the industry's average today, if you can believe this, in an 8-hour workday is only 3.4 hours of productive utilization in an 8-hour workday. And that is the economic pain point we're focused on solving at Advanced Aircraft Company, is to enable those drone pilots to cover much larger areas per day, making our customers significantly more profitable, which will then enable many more industries to start accessing data that's been gathered by drones. So that's the top level overview of AAC and the economic piece we're focused on solving.
Building on that, how does Advanced Aircraft Company extend the productivity of the pilots?
Yeah, great question. So our first product was the aircraft itself, so hardware. And our hardware improves the productivity in a few different ways. The first is it's not simply a battery-powered drone. It has a series hybrid electric propulsion system in it. And this propulsion system is burning gasoline in a computer-controlled, fuel-injected engine that's turning a high-frequency AC generator, and that AC electrical power is being actively rectified using MOSFETs back to 48 volts DC of electricity. Also on that DC electric bus is a much smaller lithium polymer battery pack, and then electrical power is drawn off that DC bus to run the motor controllers, spin the motors, spin the props. What that means is we have about 8 times more useful energy on the aircraft than we would if it were simply a battery-powered drone. And that makes it fly a lot longer. And since the aircraft can fly a lot longer, you're not stopping to change batteries every 20 minutes, lets the drone spend more time in the air collecting data, less time or no time needing to fly back and forth to swap out batteries and get batteries recharged.
How else are you improving productivity?
We've heard a lot of customers say maintenance, repair, and overhaul is a big pain point that really impacts productivity. One of the things that's unique to Advanced Aircraft Company's drones, which from the manned aviation paradigm is industry standard, it's totally normal, but this is very unique in the drone space, is this whole concept of a line replaceable unit, an LRU. So all of our LRUs are IP65 rated. We can safely fly through the rain. But what this also means is all of the complicated electronics in the aircraft are inside these IP-rated LRUs. And if there's anything broken on the vehicle, you don't have to box up the entire system, ship it off to a repair facility, and wait multiple months before you get your aircraft back. That's a really tough way to run a business when your asset is down for months at a time, as is the case with most of the drones made in China. Conversely, with our solution, since we have the LRUs, we can FedEx overnight a replacement LRU. That very next morning, the longest LRU to swap out is the engine generator unit. And no joke, it can be swapped out in less than 15 minutes, a complete engine change. And then that aircraft is back out on the job site collecting revenue before lunchtime the very next day. So that's another way in which we've improved productivity. Additionally, we've heard a lot of folks say that they really need much wider environmental envelope to operate their drone in. So this is being able to operate in light rain, being able to operate on windy, gusty days, being able to operate in high temperatures and low temperatures. So you don't have to wait for that perfect day to go collect your data. You can collect data on more days than you otherwise could. So that's how the physical product itself is more productive.
What about the software, Bill? How does that play into the productivity?
We've heard a lot from customers that they'll spend day one out on the job site and they spend day two back in the office trying to format all of their data correctly to load it into the next step in the value chain. And this is, for example, in a survey and mapping use case, the typical process that happens is PPK, post-process kinematics, where you either have your own base station or use the US government Corps base station. You got to wait 24 hours to download that data, but you have to pull the pictures off the camera and you have to pull the data log off of your positioning system, and you got to match all that off. And oftentimes it's a very buggy process. So another way we're selling productivity is formatting through software on the digital platform that's now being built out with the aircraft, such that by the time the aircraft lands, it's already geotagged with that accurate position information, and it's ready to go straight into your photogrammetry software of choice. And you're not spending a second day back in the office just trying to format your data to get it ready for photogrammetry. So that's another example in which how we sell greater productivity.
What's the history behind the technology?
Prior to Advanced Aircraft Company, I worked at NASA Langley Research Center as an aerospace engineer. And I got to work a UAS project there called Grease Lightning, which is a tilt wing that can take off and land vertically like a multi-rotor and transition into fixed wing flight. While there, we did some initial investigations into hybrid electric propulsion, and is something that I personally found very interesting. And then at Advanced Aircraft Company, we realized the better business model is for us to focus on the aircraft and at the system level, and to use partners that put together the engine technology. So to use an analogy, we're kind of like Boeing, we're the airframer, and we work with engine companies like General Electric or Rolls-Royce or Pratt & Whitney, those engine companies, to actually do the engine system. And so right now on the products we sell today, we work with a company called Pegasus to make those engines that go on our aircraft.
Who designs the engines?
We list a whole bunch of systems interface requirements, and this is a relationship we work through over a couple years. And then they have their product, and then we iterate back and forth to find the right system interfaces that are optimal at the vehicle system level. And we're also working on growing our supplier base too, just like Boeing works with GE, Rolls-Royce, and Pratt & Whitney. But Pegasus, they're the farthest along from a hybrid electric propulsion system. And we are very glad to be having a partnership with them.
Okay, so you have one major UAS in production now. It's called the Hammer, is that right?
Yes, it is. Yep. Hammer, we pronounce it hammer like the tool you swing and pound a nail. And it stands for Hybrid Advanced Multi-Rotor. That's the product that's in production today. And a future product is Grease Lightning. And that's still a few years out, but that's a very compelling product in its own right.
Is it a multi-rotor or a fixed wing?
So Hammer is a multi-rotor. Often in the drone industry, when people talk hybrid, they're referring to like a hybrid quad configuration as opposed to hybrid electric propulsion. So hybrid quad configuration is like a quadcopter and a fixed wing airplane having a baby where you just strap on 4 lift props on a fixed wing. So our drone is not that. Our drone is a multi-rotor with a series hybrid electric propulsion system on it. A good analogy would be like a hybrid car where you've got a gas engine and you've got batteries. And a hybrid car can drive dramatically farther distances than an all battery powered car for equivalent level size and cost of the car. So we're much more like a hybrid car as opposed to an all battery powered car.
Bill, give us a sense of how large the Hammer drone is.
Rotors turning is actually about 11 feet wide. So it's a pretty big multi-rotor. However, it quickly packs down and fits in a case. I've got a Ford C-Max, which is a hatchback hybrid made by Ford, obviously. And it fits inside the back of my C-Max. And we've demonstrated 4 minutes from the time you put the car in park to pull the case out, assemble the drone, turn everything on, and have it up in the air flying. So even though it is a large drone, it very quickly packs down and into something you can fit in a hatchback car. You don't even need a pickup truck.
What type of applications is it designed for?
We're focused on two markets right now. The first is survey and mapping, and the second is infrastructure inspection. One example in the survey mapping market. So we're speaking with a large open pit mining company, and the value proposition to them is they're moving a lot of soil every day, and they need to understand the slopes of their open pit mine. And the more accurately they can measure that, the steeper they can make it and still be safe. And so doing it the old-fashioned way with surveyors pulling elevations at every 30 to 50 feet, that's not a lot of resolution. But with a drone, you can get a resolution on the order of inches. So as your mine gets deeper and as you can safely make the slope steeper, that's a lot less material you have to move. And there's regulatory limits there on, for a given soil type, how steep the wall can be to still keep the mine safe. And the more accurately that can be measured, and the more often you can make those measurements, you can optimize the project planning of what soil needs to get moved. And that racks up very quickly to some very big dollars. So the economic value proposition to them is to save a foot at the bottom of the mine, literally is millions of dollars of soil that doesn't have to be moved if they can measure that more accurately. And these mines are already big into using battery-powered drones to perform these measurements, and they're getting sick and tired of changing batteries every 20 minutes, and it's really hurting the productivity of the drone team. That customer is insensitive to the purchase price of the drone. It's really insignificant how much the drone costs, because the value that data can provide is worth so much more than the cost of the drone itself. So that's a good example of a use case where it makes sense to buy a high performance drone made all in the USA to collect data to enable that enterprise corporation to manage themselves much more efficiently.
Who's your ideal customer?
Obviously, it's a very open-ended question. So I often give an open answer response is, well, assume you had a magic carpet and your magic carpet could fly hours at a time. What would be a good use case where it doesn't really matter the purchase price of the aircraft, but having that capability to collect data for hours at a time is worth a lot more to how you would manage that enterprise more efficiently. So any use case where the need to fly hours at a time instead of only 20 minutes at a time is enabling some other business value proposition further up the value chain.
What's the longest time that the Hammer has flown?
The longest flight time drone we have that we've flown is 3.5 hours. And I know there are others that have longer flight times than that, but we're actually purposely focused on not optimizing the aircraft to be a record breaker. It's less important to us to set records. What is important to us is the abilities, because that's really what makes the customer buy it or not. And it's interesting that there's an asymptotic improvement of productivity as a function of the flight time of the drone. For example, if your pilots work 8-hour workdays and you can move the flight time from 8 hours to 9 hours, there's zero productivity improvement because the pilots are going home at 8 hours, or you have to start paying for multiple pilot crews. But conversely, going from a 20-minute flight time, doubling it to, say, a 40-minute flight time, that double of flight time from 20 minutes to 40 minutes has a significant improvement in productivity. And going from 1 hour to 2 hour flight time also has a pretty significant improvement in productivity. But going from 2 hours to 4 hours is it's a marginal improvement in productivity. And then going from 4 hours to 8 hours is a little bit smaller improvement in productivity. So we're trying to find what is the overall, our optimization metric is what maximizes the profitability of our customers. So if we optimize purely on flight time, we're also sacrificing the ability to fly through rain. We're sacrificing the ability to be redundant to a motor failure. We're sacrificing the ability to fly on a very gusty day. So we're trying to find what's that optimal solution for the customer that enables them to maximize their profit margins. So we don't want to optimize any one objective function, but what's the overall optimal solution for the customer?
Given that a pilot has to remain attentive to the craft and the situation, what is the optimum flight time? 3.5 hours is a long time.
The answer depends on how actively the pilot needs to be engaged. So if you are, say, doing a survey mapping mission where you're relatively up high, clear of obstacles, and you got the drone programmed up doing its lawnmower pattern over the area of interest, and the pilot's just there to make sure the radio link is still connected and the drone is still flying, doing what it's supposed to be doing, in that case, the bandwidth required of the human is relatively low. So doing a multi-hour mission is not a big deal. But conversely, say you're doing a use case where the pilot has to be hands on the controls the whole time, the opposite end of the spectrum, that's much more bandwidth intensive for the human. And that's often a use case where flying a battery-powered multi-rotor is sufficient, because the human to stay actively in the loop with that much concentration is hard to do for more than 20 minutes at a time. So these are the use cases where you're flying a lot of waypoint missions or three-dimensional waypoint missions, and the pilot is simply supervising and checking for other air traffic in the area, but not directly manipulating the controls of the aircraft.
I want to go back to the engines for a second. Are there engines that are electric and engines that are gas? Or is it really one engine that is running on gas and electricity?
When I use the word engine, I'm referring to the device that consumes gasoline and spins a crankshaft. And when I use the word motor, I'm referring to the device that consumes electricity and spins a crankshaft. So the basic architecture of the system as we have it now, we have one engine, one generator, and 6 electric motors. So the engine is computer-controlled, fuel-injected, and it's a 2-stroke engine. And often when people think of 2-stroke engines, they think of their chainsaw or their weed whacker, something very cantankerous. And I admit I've dropped a few F-bombs trying to get my weed whacker started after it's been sitting for a little while. And it's not that it's a 2-stroke engine, it's that you're working with a carburetor. And carburetors are not very reliable solutions, nor are they all that fuel efficient. So like ethanol tends to gunk up the orifices in the carburetor and in the diaphragm. So this engine is computer controlled, fuel injected like a modern automobile. There is no carburetor on it. So there's a propulsion system computer that's looking at the power required, the air temperature, the air pressure, and the RPM, and it's determining exactly how much fuel to inject. And it does all the priming as required for starting. So the computers are handling a lot of things that normally you'd have to inject on as the human to prime it and to turn on the choke lever and pull start it. None of that is the case here. You just simply have one switch, run or kill, and the computers on board the aircraft handle everything else from that point there.
In developing the system, what were the key challenges that you had to overcome?
It's interesting. So with my time at NASA, I was blessed with the opportunity to work a lot of projects that actually went to flight testing, which is pretty cool. And at NASA, it's all about technology development and to prove feasibility of technologies. I mean, that's the sexy research stuff. But then at AAC, it is sort of, it was an awakening moment for me, because at AAC, we not only want to research a technology, but we have to develop a commercializable product. And going from technology to product has it has been the largest challenge that we've been working through at AAC. I've gained a new appreciation for automobile manufacturers. Like 30 years ago with your car, you're always dinking with it to keep the car running nice. But a modern automobile, it's amazing how reliable it is. You just put the key in or push the button for push button start, and it works every single time. It's really impressive. So I would say the commercialization to go from that prototype, like a car 30 years ago that you're always sort of dinking with, to an enterprise level product that you just turn it on and it works every single time, to have excellent dispatch reliability. It's all those ilities. Getting the ilities right is systems engineering, dotting all of your I's and crossing all the T's. To make sure it's durable, reliable, maintainable, user-friendly. That has been the biggest challenge, is to actually deliver in practice something that's durable, reliable, maintainable. I would say that's been the biggest challenge that we've had to overcome at Advanced Aircraft Company.
How long did it take to get to that level with the Hammer?
So let's see. I left NASA in May of 2017, and we started shipping hammers right at the end of last year. So we're talking almost 4 years of R&D to the point where we had the product where I was comfortable standing behind it. And that was still beta, honestly, too. So now we're through beta, and it's an even better product than it was before.
You mentioned the Green Lightning UAS. Can you give us some background on the development and what it's designed to do?
When I worked for NASA as an aerospace engineer, I led the Grease Lightning project. I did the conceptual design of that aircraft and led the project through its detailed design, fabrication, and flight testing. And we built it, we flew it. There's a public affairs video up on YouTube. Just you can search NASA Grease Lightning to watch the NASA public affairs video. Pretty cool video, by the way, but I'm biased. We finished that project. We said this technology is feasible. We slapped the table and we quite literally put that aircraft up on a shelf, broke up the team to go work the next jobs. And that's when I said to myself, do I still want to be a government civil servant researching technology, or do I want to see this technology that we just proved was feasible commercialized? And that was the moment that I walked through, is like, okay, maybe I do want to transition out of the government and commercialize UAS technology. So I left NASA to commercialize Grease Lightning. And we realized pretty quickly that it was going to be a hard sell. So Grease Lightning, well, first of all, Hammer is a significant leapfrog in performance beyond what is in the drone industry today. And Grease Lightning is a significant leapfrog in performance beyond our Hammer product line. So Grease Lightning can take off and land vertically like a multi-rotor, maneuver like a multi-rotor, and fly missions of 14 to 20 hours per flight. So let's use the use case of linear infrastructure inspection as an example. So the typical battery-powered multi-rotor can do about 4 miles of linear infrastructure per flight. Using similar assumptions, a Hammer can do about 40 miles of linear infrastructure per flight. Now, granted, these are all BV loss use cases, so the regulatory piece still has to come together. But let's just, for the sake of discussion, to talk about the vehicle capability, assume the operator has permission for BV loss operations. So battery-powered multi-rotor, about 4 miles of linear infrastructure per flight. Hammer can do about 40 miles of linear infrastructure per flight. Grease Lightning can do about 450 miles of linear infrastructure per flight. So another massive leapfrog. And so what's an example market opportunity for a vehicle like Grease Lightning? Let's say, for example, natural gas transmission lines. If you talk to the gas companies, you typically would hear leakage rates of about 3%. Some EPA estimates say the leakage rates in the some transmission lines can be over 10%. If we just assume the leakage rate is 4%, 4% times the quantity of natural gas produced in the United States every year times the price per cubic foot of natural gas is about $4.2 billion. And you ask yourself, whoa, why are we losing $4.2 billion every single year in this country alone to fugitive methane emissions, natural gas emissions just coming out of transmission pipes? And the answer is there's really no good way to inspect those at enough frequency. But say you had a magic carpet you would want your magic carpet to be able to go quickly, such that you could get a low cost per mile. So, say you'd want your magic carpet doing about 50 miles per hour, whipping down a pipeline to get a low cost per mile. But the challenge with going that fast is you'd have to set your sensor threshold so low, you'd probably also be getting a bunch of false positives. So you would want your magic carpet to stop and stare, take a closer look, confirm or deny whether there is or is not a leak there. If there is, tag the exact weld on that pipeline that has the leak, and then accelerate back out again and go whipping down that pipeline. Well, that magic carpet is grease lightning. And that's an example use case of where advanced aircraft company is headed in the future. And there are a number of interesting opportunities for grease lightning, but those are the markets we're going after with grease lightning moving forward.
When you mention gas line inspections, I think about the Alaska pipeline in the cold and harsh conditions. Are those conditions being taken into consideration in the design of grease lightning?
Yes, absolutely. So, for example, with our Hammer product line is to come out with a cold weather package. So conceptually, since we're burning liquid fuels in an air-breathing engine, we have the capability of operating at much lower temperatures. And in fact, cold temperatures improve the performance of the aircraft. Unlike a battery-powered multi-rotor, with batteries, when batteries are cold, you cannot extract as much energy from them. But with an air-breathing engine, when it's cold, you actually can produce more power and you're more efficient. So the performance is actually better in those difficult cold conditions. However, one of the things that we're going to include in our cold weather package would be some changes to the cooling system for the lower temperatures, as well as some heaters for the smaller LiPo battery pack in the aircraft to keep those at an appropriate temperature control, such that if you do need to rely on those batteries mid-flight and they've cold soaked because you've been flying so long, we don't want them to cold soak. If the engine fails and the batteries need to take over to keep the drone flying, or for whatever reason you need to command the engine to turn off mid-flight, the batteries are there. So a cold weather package is something that's coming in the future to enable safe operations in Arctic conditions.
Is grease lightning similar in design to the Hammer?
That's actually something we're talking a lot about with some customer discovery calls. So from an engineering perspective, the lower end of a reasonable scaling range for grease lightning is about a 55-pound maximum takeoff weight. So this would be a wingspan of about 10 feet. The upper end of a reasonable scaling range for the technology is about 4,000-pound aircraft, something at about a 40-foot wingspan. This would be something that could carry about 4 people or so. As the vehicle gets bigger than that, the design makes less sense, but those are the two bounds of the scaling range that make good sense for the grease lightning technology. One of the things we're trying to decide is what is the right scale, what's best for the market. So in one sense, having the 55-pound vehicle would be nice for the potential simplified regulatory framework. But a lot of folks want to be carrying bigger sensors, like, for example, LiDAR sensors. A high-quality LiDAR system is over 10 pounds to get high flash rates and high accuracy. And then oftentimes you don't simply want to carry LiDAR, you want to carry other sensors too. So one of the things we're debating is, should we make grease lightning at the 55-pound scale, or should it be something bigger than that? Like, for example, should it be a 300-pound aircraft and maybe a 15 or 16-foot wingspan that can carry 50 pounds of payload, as an example? So that's one of the things we're actually still trying to decide is, what is the right product market fit for a technology like grease lightning that can cover very long distances, and how much weight should we design it to carry? And we haven't decided that answer yet.
Can you talk about the ease of use from the operator's perspective?
Yes, a great question. And that's one of our value propositions is ease of use. To first level set expectations, typical UAS operations of today, if you have a large area to map or inspect, you bring the drone itself, and that's what most people think about and talk about. And then these big drones, simultaneously, you got to put 6 batteries in it to fly. And you need a minimum of 4 sets of batteries, because 1 set for the aircraft and another 3 sets, because it takes 3 times longer to let the batteries cool and rest and then recharge by the time they're ready to get put back in the aircraft again. And then, so that means you need at least 3 sets of battery chargers and a generator to run all those battery chargers, and an extra person to babysit the generator and babysit the battery chargers, such that you always have fresh batteries ready to go. And so if we consider that customer experience and compare that with our product, you simply put the fuel right into the aircraft. So that third person, like normally you have a pilot and a sensor operator and a third person who does nothing but babysit the battery charger and the generator. So that third person would no longer be needed relative to a big multi-rotor operation. All those things that you'd normally have to set up. You got to pull the generator of the truck, you got the batteries set up. So all that logistical footprint is significantly reduced. From an actual piloting perspective, it flies just like any other multi-rotor. The only difference is you have 1 extra switch to tell the engine to run or to kill. But from a piloting perspective, it flies just like other multi-rotors.
Is there anything about the technology that we missed that we should talk about?
I think we covered our bases pretty well on Hammer. And then for Grease Lightning, use cases for Grease Lightning is as a tactical UAS for ISR needs for military organizations, linear infrastructure inspection, and then also package delivery is a really interesting. So that's not really a market that has blossomed yet, but a very interesting product market fit for that use case as well. So those would be the 3 markets that I just want to touch on.
How about the transition from NASA to the commercial arena? What was that like?
Talk about a learning experience for me. So I should first maybe just say my background. So I've been around aviation since I was a kid. I started flying when I was 13 years old in gliders. And I have my private pilot license, and I'm licensed in gliders, single engine, multi-engine, and instrument rating. I currently own my own airplane. It's a Piper Lance, 6-seater, 1 prop on the nose, retractable landing gear. I went to college at Purdue University, got a degree in aeronautical engineering, and graduated 4th in my class. Then I served in the Marine Corps as an artillery officer, was deployed to Afghanistan in 2011. And I worked at NASA as an aerospace engineer. So my background has been very technical focused. What's not been in my background is the business experience. And so this is my first rodeo as starting a company. And so there's a lot to learn when it's your first rodeo. One of the benefits I had was perspective. Leadership is not new to me. So in my time leading Marines in the Marine Corps and the projects I led at NASA, I knew it was very important to surround myself with folks that had skill sets that I don't have. So right from the beginning, it was always important to find advisors and people to work with. So my business counterpart right now, Aaron Frank, he's our COO. So I'm the engineer that's learning the business world, but I stayed in a Holiday Inn Express last night, so I learned pretty quickly. Aaron's a businessman, so he's got his undergrad in finance, he's got his MBA, he's worked with large corporates, he's been in the drone space for a while, so he's a business guy that loves the drone space. So it's a very ideal yin and yang from that perspective, and he has ideas and I'm like, we probably shouldn't go down this path for this reason. And then I have ideas and he can be that same sounding board back to me for this. And so one of the things I used to tell my sergeants before going out on a foot patrol in Afghanistan, if I'm about to step on a landmine, please tell me. And there's been a number of situations where I'm learning the business world where I've fortunately had the guidance of others that have been there a few times before to say, hey, Bill, there's a landmine you're about to step on. I would suggest you turn left here. And that's sort of a trite example, but it's illustrative. And so one of the biggest challenges that's been is the technology piece is difficult, but it's a solvable problem. The business piece, while it's not nearly as technically difficult, it's significantly more labor intensive. of getting the business together. And it's just effort and it's a grind and it's just a lot of time. So that's one thing I didn't fully appreciate when I started this journey, is just how much effort it takes to get a business together as opposed to simply getting a product together.
Well, based on that experience, what advice would you give to other entrepreneurs?
So advice number one is be very critical of yourself and identify what your gaps are. And just be very honest with yourself to be like, hey, I have the following gaps. I need to find advisors. I need to find co-founders. I need to find business partners, insert the role as required to make sure that those gaps are covered by the other people you surround yourself by. So that would really be the first piece of advice. The second piece of advice is General Eisenhower, I believe, had this quote, and also President Eisenhower. I might be butchering the quote, but it was something along the lines that plans are worthless, but planning is invaluable. Or sort of another phrase is no business plan survives first contact with the customer. But having said that, though, like what Eisenhower said, planning is super important, but don't be afraid to pivot. So like, as I mentioned, I left NASA with the intention of commercializing grease lightning, but we pivoted to do Hammer because it's something we could do with less startup capital and something that has a commercial fit on a much shorter timeline. So planning is very important because it helps you make decisions in real time, but don't be married to the plan directly. Be open to pivoting. So I'd say that'd be number two. And number three is really make sure you have a good product market fit. When you're trying to do your calls with prospective customers and it's just not landing, you're probably solving a problem that isn't really a problem for them. So really focus on making sure you understand the problem that your customers have and that your product actually solves their problem as opposed to the problem you think they have. And that's certainly had some nuances. Like, for example, now we're building out the digital platform to go with our aircraft. That's an example of that. So we got the high performance drone, and we've had customers say, Bill, your drone is great, but it's not sufficient to make a sale. And we need A, B, and C. And so make sure you understand exactly what the customer needs. Define what success looks like for your customer. Maybe that's a very succinct way to say it is success means we can do the following items, and make sure you really understand that, because if you're missing a piece, you're never going to get the sale to close.
Bill, what's next for Advanced Aircraft Company?
What's next for us is scaling. So we've got the Hammer product line that's out now. And actually, due to customer demand, we're making a big brother of Hammer. We're calling that Hammer Neo, new engine option. And we're doubling the electrical power output coming off of that so we can lift much heavier payloads. So that's the next step for Advanced Aircraft Company is Hammer Neo, new engine option to lift heavier payloads and fly a long time. And then after that is Grease Lightning, which is something we talked about a little bit earlier. So that's where Advanced Aircraft Company is headed.
Bill, when people ask if a long-duration flight system is right for them, how do you respond?
First of all, advancedaircraftcompany.com is our website. And as you think about the drone industry today and the use cases for drones, think about an operational concept differently. So much of the industry today, concept of operations of drones are built around, we can fly about 20 minutes. So how would we collect this data? And I would really encourage the audience to think about, well, if you weren't limited to a drone that can fly 20 minutes at a time, that could persistently hover and maneuver for hours at a time, how would you operate differently? And so any use case where you need a long flight time and still maintain the ability to persistently hover or to fly slowly is a great fit for Advanced Aircraft Companies. So for example, LiDAR data collection. It's really difficult to put LiDAR on a hybrid quad vehicle or a fixed wing vehicle because the aircraft flies too fast for the sensor. A multi-rotor is normally what you have to carry LiDAR on so the drone can travel at the speed that the sensor wants it to, like normally about 15 miles per hour or so, which is much too slow for wing-borne flight for most things. That's a great use case where a product like ours. So now we can fly at the speed you want and fly hours at a time. So now we're getting many more acres per flight. So to give one example on that data point, if you're, say, just doing a camera photogrammetry type mapping mission, typical battery-powered multi-rotor can map 100 to 200 acres per flight, depending on assumptions. Using similar assumptions with the Hammer, we can map 800 to 1,400 acres per flight. So it's just a huge leapfrog increase in productivity that's provided. So in conclusion, think about how drone operations could be done differently to be more efficient if you had a drone that could fly a lot longer.
And for my final question, Bill, what message would you like to leave regarding the drone industry?
As I mentioned earlier, the first wave of, well, you could actually argue the first wave of the drone industry was the DoD use of drones. And then the second wave might have been the consumer industry. The third wave of the drone industry is enterprise use of drones. So whether this is for data collection or package delivery, the next frontier of the drone industry, and this is still a very early market, is how do large enterprises manage their enterprises more efficiently, which makes the world a better place. And that's what I find very exciting about the drone industry is this third wave of the drone industry is coming in, and that wave is starting to land now. And the next 5 to 10 years of the drone industry is going to see an incredible growth in enterprise use of drones.
That's it for episode 337 of the Drone Radio Show. I hope you enjoyed hearing from Bill Fredericks of Advanced Aircraft Company. I want to thank Bill for taking the time to speak with me. If you want to learn more about Advanced Aircraft Company or want to connect with Bill, check out the webpage at advancedaircraftcompany.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.